Hello everyone, today let's solve the problem number 235, lowest common ancestor of a binary search tree. Right, so what the question states here, we are given the root of the binary search tree. Right, so you can clearly see here we are given the root of the binary search tree. Right, so and we have been given two nodes P and Q also. See here, P and Q. Right, P we have been given 2 and Q we have been given 8 here. So we have to find the lowest common ancestor LCA of P and Q. See, we have to find out the LCA of this one and this one, P and Q. Also, we have been given the root of the binary search tree as well, right? So here we have been given value for the P and Q. We have to find the lowest common ancestor or the LCA for P and Q. In the binary search tree, left subtree is less than root. Left subtree is always less than root. You can clearly see here. See. So just give me a second here. 1 second. See here, 6. 2 is less than 6 and this one right subtree will always be greater than the root. See here, 8 is greater than 6. Same goes with everything here. See, 0 is less than 2 and 4 is greater than 2. 4 is greater than 2. Same thing here, 3 is less than 4 and 5 is less than 5 is greater than 4. Same goes with the right one as well, right node as well. So see here, 7 is less than 8 and 9 is greater than 8. So this is completely balanced binary search tree, right? So this is completely balanced binary search tree, right? So here in this case, in the binary search tree, left subtree is always less than root and right subtree is always greater than root, right? So the LCA of the lowest node that has both P and Q as its descendants, uh, the LCA is the lowest node that has both P and Q as its descendants. That's what they have given in the question, right? The LCA is the lowest node that has both P and Q as descendants, right? LCA is nothing but the lowest common ancestor, right? Lowest common ancestor. LCA, the definition says that it is the lowest node that has both P and Q as its descendants, right? It can be descendant of itself too. Suppose this one, this can be descendant of itself, 2 can be descendant of itself. Just for the sake of example, 8 can be descendant of itself, right? So that's what I'm saying, that's what I wanted to say. We have to return the node that is the LCA. We have to return the node that is LCA based on the P and Q that they have given. We have to return the node that is the LCA or the lowest common ancestor. Let's consider the first example. So now we have the question. Now we have the understanding of the question. Let's discuss the approach followed by the complexities and then let's write the code. First, as usual, let's discuss the approach. Right, we will start with the root 6. We will start with the root 6. So we have been given P equals 2 and Q equals 8 for the first one. So I'll show for the first one. You can carry on with the same steps, or you can just do it in the same way that I do it for the example 1. For the example 2, you can just go with the same steps for the example 2 as I show for the example 1, right? So here for the example 1, we have been given P equals to 2 and Q equals 8, right? So here we will start with 6. We will start with 6, right? So one on left and one on right. So this we have 2 is on the left side and 8 we have on the right side. So let me change the color. Just give me a second here. Sorry. I erased the entire thing. I think this is fine. So let me do one thing. Let's consider this one. So here first we have 6 and 8. So we have been given P equals to 2 and Q equals 8. So which color did I opt? Just give me a second, man. Let me opt some different color. So this is fine. P equals to 2 and Q equals 8 we have. So here P equals to 2, P equals to 2 is uh, actually less than 6. 2 is less than 6 and Q equals to 8 is this one. What do you call? 8 is greater than 6. 8 is greater than 6. So one on the left and one on the right we can consider in this way, right? So 6 is the lowest common ancestor. So 6 is the lowest common ancestor for this one. So 6 is the lowest common ancestor, right? So here 2 is less than 6. This is correct, and Q8 is greater than 6. So according to the BST rule, this matches correctly, and 6 is the lowest common ancestor. BST rule, what it says, the left subtree, the value of the left subtree, this one has to be small, and the value of the right subtree, this has to be greater than the root. So here 6 we have, 2 is smaller, 2 is smaller than this one, what do we call 6, and 8 is greater than 6, 8 is greater than 6. So see here, p equals, we have been given 2, 2 is smaller than 6, and q we have been given 8, 8 is greater than 6. So this works, right? So this absolutely satisfy the condition. So 6 we can consider the lowest common ancestor here, right? So BST rule that we used is p dot value less than the root dot val, and q dot value is less than the root dot val, both in the left subtree, both in the left subtree, right? Both in the left subtree. Also p dot value greater than root dot value, and q dot value greater than root dot value, both in the right subtree, both in the right subtree. Else split happens here, this root is nothing but the else here. Else split happens here, this root is nothing but the else here. See, let's go with the second example. Now we are done with the approach part. Still, let's go with the second one. See here, we have p equals to 2, q equals to 4. So this one we have to consider. P equals to 2, q equals 4. This one, not 8. So p equals to 2, q is nothing but 4. So the output here as this one, the output is 2. The output is 2 because we have been given p equals to 2, q equals 4. The LC of nodes 2 and 4 is 2 because node can be descendant of itself. 2 is descendant on itself. So accordingly with the condition, or in the criteria, not the condition. Yeah, you can consider that one as condition as well. Accordingly with the condition, so a node can be descendant on itself. They have given in the question clearly. So this one, LCA of 4 and 2. So these two I'm speaking of, LCA of 4 and 2 is 2, is 2 because a node is descendant on itself. They have clearly mentioned in the question, right? According to the LCA definition. So we have to consider 2 here as the LCA, or the lowest common ancestor. Right. I hope this part is completely clear, man. Question. They have given us wonderful examples just for the sake of understanding here. They have given wonderful examples just for the sake of understanding. Here we have p, 2, q, and 1. We have only two nodes, so quite obviously the root will be here. This one, what do we call, uh, lowest common ancestor. So we have to return 2 here in this case. This is fine. Right now, we have the understanding of the this one. We have already discussed the approach, right? So now we have the understanding of the question. Also, we have discussed the approach accordingly with the question. Now, before writing the code, let's discuss the complexities, right? So one thing I want to tell you here is we will not be going with the recursion. Instead, we'll be going with the iteration. We will be going with the iteration. As this is binary search tree, we will be going with the iteration. So overall time complexity would lead to big of log n because this is binary search tree, right? So the time complexity would lead to big of logarithmic n because we are making use of the balanced binary search tree, or we are going with a balanced binary search tree. We have to move down one side at each step, right? And for the balanced binary search tree, so the overall time complexity would be big of logarithmic n. So we will be going with the iterative stack because we can reduce the space complexity from big of n to big of 1. So recursion depth would be big of n, or we will just consider this one, height of the tree for the skewed tree, right? So instead we can just go with the iteration that would lead us to the big of 1, big of 1, because we will be making use of the iterative solution, means we will not be making use of any extra memory, right? So here instead of the recursion we'll be going with the iterative solution, and the space complexity would be big of 1 instead of big of n, and also the time complexity would be big of logarithmic n instead of this one, big of n. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of logarithmic n and big of 1 respectively. Right now we have the understanding of the approach and the complexities quickly, as correctly. So as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So initially we have to traverse the tree until we find the split point or one of the nodes accordingly with the approach that we discussed. So I'll just go with the while loop here. While root not equal to null, then what we need to do, we have to check whether both nodes are in the left subtree. Check whether both nodes are in the left tree. Else we have to check in the right subtree. That's what we need to do. Right. So first, if the both nodes are in left subtree, then we can write in this way by making use of the if condition. So if this is p dot val less than root dot val and this one q dot val less than root dot val, then here what we will do, we will assign root equals root dot left. So this is for the condition if when both the nodes are in the left subtree. Same thing, let me copy here, let me copy here, um, let me do it for the right subtree as well. But only thing is this one we have to change here from this one, what do we call, root equals root dot right. Also this, as we are making use of binary search tree, this one has to be greater, a right subtree has to be greater. Why this is not considering this symbol, man? So this is fine, this one is fine, root dot right. So else one more condition is there, if the split happens here, then this is the lowest common ancestor, means a node can be descendant on itself as well. So else we just have to return the root, right? So here let me write in this way, else return root, return root. So did I miss anything? So we have to go with the fallback as well. So input guarantees p and q exist, right? So here let's go with the fallback and let's return null here. This is fine. Let's return null here. So this is it for the code. Let me hit the run button. So this is very simple, man. Anyways, we are going with the iterative solution rather than the this one recursive solution here. So here you can clearly see the sample test cases are getting passed. So let me hit the submit button now. So here you can clearly see all the test cases are getting passed, means the code works absolutely correct for the code works absolutely correct in this case, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.